Okay, fine. Fine, then we'll proceed. Okay, so next we would like to look at the comparable and comparator things, right? So first thing is, let's start with this problem, okay, that we would like, let's say we have an array of account, okay, and we would like to sort them. How will you sort an array of account? What is needed if you want to sort? Okay, so maybe we may initially start with a problem which is about sorting an array of integer. Okay, yeah, how will you sort an array of int? See, it's like for this problem, we want to have a, let's say we would like to have a method, a public method which returns void. Name of the method may be sort, parameter may be, you want to have account array as a parameter. Okay, for this one, okay, we would like to have a public method returns void. Name of the method is sort, int array is the parameter. Okay, yeah. So how will you sort it? Suppose it's an int array. Comparing the, yeah, so what is needed here, so whatever algorithm you may use, there are various algorithms available, but one important thing is, the important operation to be available is, for integer that kind of an operation is available, right? We have the comparison operation, right? You may use less than, or maybe you might be using greater than, some such comparisons will be needed. Okay, fine. So important thing is, okay, and so if you want to do this, yes, we need to use a comparison operator. So what about this? How is this different? Oh, we need a comparison operation, right? Okay. So as far as we understand the operations of less and greater than, those operators, they are available for the primitives, only for the numeric rather, and it's not for boolean also. You can say true is less than false or false less than true or something like that, right? But it's available for numeric type. So what about the classes which we define? Oh, we have our classes, right? What about the reference type? The point is, what about the reference type? Comparison is needed for them. Okay, fine. So now, suppose I give you a list of accounts and I say put them in order. Okay, how would you put them in order? By, you'll order them by, yeah. Account has what? Account number, name, balance. If I say put this account in order, there's no other instruction I'm saying. Okay, just put them in order. How will you order them? Yeah. Yeah. How will you order the account objects? I've just said put them in order then. Simply, whichever comes first. What is first? How do you say this is first? Which is inserted first in the, inserted first in the array. So whatever order of the, so then there is no question of sorting. That's the original order, right? But you are saying, oh, put them in order. Yeah. Yeah. Naturally, what comes for putting them in order, right? We'll most likely be ordering them by the account number. Fine. If someone says, oh, these are account objects, sir, just put them in order. How will you order them? Fine. Based on account number. Fine. So this is what we call as the natural ordering. Okay. Fine. So see, not all objects will have a natural ordering, right? See, if I have objects of the integer class, if they have to be put in order, oh, they have a numeric value, right? And if it is numeric, we know the ordering is there. See, ordering is defined for numeric type. The comparison is available for numeric. Okay. And if someone says, okay, these are account objects, let's put them in order, then okay. See, for everything, a natural order may not exist. Fine. What I'm talking about here is, okay, account number defines the natural ordering for objects of account type. Okay. When see, all classes may not have a natural ordering, right? Okay. So here now we were looking at this interface called comparable. Okay. So java.lang package has an interface called comparable. Comparable interface is implemented, okay, by all those classes whose objects have a natural ordering. When integer class, if someone says, oh, they have a natural ordering, right? If the class is integer, right, they have a natural ordering, right? If the class is rectangle, or let's say we have the class called color, yeah, there is a class called color. Does it have a natural ordering? So what are the colors? Oh, we have red, green, blue, all these. Right? How do we compare them? Red greater than blue or something like that. So not every class will have a natural ordering, right? Okay. So only those classes which have a natural or whose objects have a natural ordering, they should be implementing the comparable interface. Okay. Fine. So not everything will have a will be comparable, but yes, wherever we feel this has a natural ordering, we may go for implementing the comparable interface. Okay. So comparable interface Okay. Right. So comparable interface has an abstract method. Okay. Okay. Let's see what is that abstract method. Okay. So we have a method like this. There is a abstract method public method name. Method returns int. Name of the method is compare to. Parameter. Oh. So what should be the parameter compared to method? Yeah, integer. There is one account object. Let's say, okay, we are saying account implements comparable, and if there is an account object, I'll be comparing with account. See, two accounts will have to be compared, right? Okay, so this basically compared to method, and okay, I'll not say what is the parameter currently. Okay, it has a parameter. Okay, there's some parameter. Single parameter will be there. Okay. Okay, for the time being, I'll say, okay, you're going to compare it with some object. And you're going to compare it with some object, right? Okay, and this method, the meaning of the return value of the method is like this. Okay, so if we have two comparable objects, A and B. Okay, if there are two comparable objects, A and B. Okay, then the value int value returned by the compare to method, right? We should be able to use A dot compare to B. Okay, and that will give us a integer value. If this return value, okay, if this is less than 0, fine, either it is less than 0, equal to 0, or greater than 0. Okay, so if it is less than 0, then this is considered as fine. So this should be interpreted as A is less than B. Okay, and if it turns out to be greater than 0, then it should be considered as A greater than B. Fine. If it is equal to 0, then we'll say A is equivalent to B. Okay. Okay. Fine. And normally, when we have this, right, if it is turning out to be 0, you should see that normally it should be consistent with our equals method, and then A equals B should also be turning out to be true. Then it is consistent with the equals method. Okay. Fine. So if we have any class whose objects have a natural ordering, then you must implement this method. Okay, it should provide the logic of comparison. How do I compare? So basically, we don't have the less than kind of a thing or greater than kind of these comparison operators available for the reference types. Fine, they're not available. Fine, but yes, because it's not applicable to all the reference types. That's one thing. Okay, so for whichever, so it is applicable to which objects? Objects which implement, whose classes are implementing the comparable interface. Yeah, so implementing comparable, so comparable interface is actually nothing but the providing the logic of comparison, whatever is the natural, for the purpose of natural ordering. Okay, so yes, we were looking at account class, fine, and natural ordering for account would be based on account number. Okay, but we can have other ordering as well. Someone can say, oh, let's put them in the order of their names. Or someone says, okay, let's put them in the order of the balances. Whatever balance they have. And if the balance happens to be same for two of them, then we'll go with the name. See, you may have some other mechanism of ordering also, but we have one natural ordering which we say is based on the account number. Right? If accounts are there, when someone just says, okay, doesn't mention any instruction, just says, oh, put them in order. Most natural thing would be to put them in the order by the account numbers. And that's why we say this is nothing but the natural ordering for accounts. Okay, now compared to, yeah, I have just said compared to takes parameter as object. Okay, fine. Let's look at this interface called comparable, how it has been defined. Okay, so we have this public interface comparable. Okay, but this is a generic interface comparable for some type T. Okay, now you should be able to understand what is the return type for the compare to method. Yeah, what's the parameter for the compare to method? T is when someone is defining comparable, he is saying, okay, comparable requires a type parameter. Not everything is comparable. If it is an account which is comparable, it should be compared with account. So if it is comparable of T, it should be compared with T. That is the whole idea. See, fine. Let's link it with the generics which we were looking at yesterday. Okay, fine. So it's something like this. I have a variable which is of type comparable of account. Right? Suppose we have a comparable of account, that some variable is there. Let's say CA. Okay, equals. Let's not worry about how it has been assigned or something. Right? CA dot compare to, I will only be able to use an account object. Fine. I cannot pass anything other than an account here. I cannot be passing a rectangle over here. Okay. Otherwise, compiler will give an error. Okay. Fine. Now, where is the logic of comparison going to be defined? Comparing two account objects. It's going to be in the account class. See, any class which has a natural ordering defines the natural ordering in that class itself. So we actually would have something like this. So whenever we use comparable, see how we use it. It's going to be like this. Oh, my class account has got a natural ordering, right? Okay, so it says it implements of account. Okay, so what's the method it needs to implement? Public int compare to, and what should be the parameter type? Account. See, in the account class, the compare to method should be comparing with the account object only. So this is what you should be defining. Fine, see this generic, fine, now you can relate with this. This one says comparable of t. What's up? So it says, yes, the compare to method will take t as a parameter. Here, when the interface was defined, it was defined as a generic interface. Any method in this can use that type parameter. Okay. Yeah. This has to be some account object, right? AC1 or something. Okay. Fine, and that would return a, this returns a int value. We understand the interpretation of int value now. How the int value is to be interpreted. See, prior to Java 8, we had only abstract methods available for interface. Okay, we had only abstract method available for interface. But after Java 8, there's something which could have been done with the comparable interface. Okay, has not been done, but I'll just show you that version of comparable if it had been modified that way. But anyway, what you could do is you can have your own sub-interface by extending this comparable. Okay, so something like this could have been a could have been a modification in the comparable interface. Let me see. Fine. Comparable of t. Okay, we'll put it as it's a comparable of t. Okay, it's not the fine. It's not there in the API, but this is a better thing which could have been done, and this could have been done from Java 8 onwards and won't break any backward compatibility. Okay, so we have the public interface, comparable of some type t. Okay, and it was already having this public interface, public method returns int. Method was compare to, parameter is t. Okay, okay, fine. So this is the abstract method, and then we can always be having a default method returns boolean. Okay, name of the method can be less than parameter t, and it's a default, so I'll have to write an implementation. And what do we do? Return this dot compare to t less than 0. Yeah. You can even add the other default method to return boolean. Okay. This one says this dot compare to t is greater than 0. Fine. And same way, the idea is you can find these kind of methods could have been easily added from Java 8 onwards in the comparable interface as a default method. And because they fine, so people can then be using it in a more meaningful way. Otherwise, each time you have to be writing less than 0 if it is less than 0. You want to compare two account objects, right? Okay, let's understand that account. Fine, let's go with this, that account implements comparable of account. Fine, we go with this definition. Yeah, we had written this earlier. Yeah, so we go with this kind of a understanding that our account implements comparable of account. Okay, Right? So every time now, see now if you this is how it has been implemented, and okay, we'll come to how do we implement this. Okay, one more thing here. Recollect all the wrapper classes. Right? For int there is an integer class, for long there is a long class. So for every primitive there is a class available, right? Okay, these classes, all of them are implementing comparable with their own type. So if it is integer, it implements comparable of integer. Right? If it is long, it is implementing comparable of long. Okay, so now can you think of how do we compare two account objects? We understand the comparison logic is to be based on account number. So in this account class, yes, how will I implement the compare to method? Account number is of type long. Okay, let's understand we are already having a private variable, type is long, account number, this is available, right? The other variables which at this moment not needed, yeah, because our logic has to be based on account number. So now can you tell me how do we implement this method? Comparison of two accounts based on their account numbers. It has to return an int value. Also understand, fine, you need to understand this, that long implements comparable of long. Okay, we know this, that long implements comparable of long. All our wrapper classes are like this. Okay, and if it is integer, it implements comparable of integer. So in the integer class, there is a comparative method, and which takes integer as a parameter and returns an int value. Yeah. Yeah. So how do we write the compare to method for account class? Yeah. Okay. Yeah. What do we return? Compare two account numbers. How do we? So what are the two account numbers? This dot account number and AC dot account number. Okay. So how are we comparing? Okay. This dot. This dot compared to this dot AC. This dot. We have to compare the account numbers, right? This dot AC. This dot account number. Okay. Now, what is this dot account number? Type is primitive long. What should be done? Casting. Okay. So we'll have to cast it into the wrapper long. Okay. Right. Then this has to be compared. AC dot account number. Okay. Fine. But this is how implementation of comparable has to be done. And for our account class, this is how we can be doing it. And pick up the account number of the current object. Fine. It is comparable, right? Long is comparable. Okay. Use fine, because we have to return an int. See, if I'll tell you a very common thing which is used in case the account number was of type int. Okay, I'll just show you what it was. Most common implementation, when the value is of type int, suppose this was like this, and if it was int here, okay, then what was the most natural implementation here? Okay, we were not doing any casting or anything. Oh, we would just simply be saying return this dot account number minus AC dot account number, and that's doing the job for me. If current object's account number is less than the given object's account number, then this will be negative. Right? So for int type, yes, this is a very common implementation that you will find. And but here, if it is not int, okay, long is already there. It's doing the logic of comparing with another long, keeping the natural ordering. So why should I worry? Fine. So this is what we do. Clear? Okay. For int type, that's a common implementation we go with. And so other things in the account class, yes, you may not change, but this is what you can do to make your account to be comparable. So when you want to compare to fine, so what will the sort method be doing? Yeah, coming back to that sort method, what should be there inside the sort method? And we started with that, right? So yeah, sort method for int array is fine. We will need a comparison, but sort method for this one, right? See, wherever comparison is needed, it would have been saying array of I. Okay, somewhere it would be like this, right? If array of I dot compare to array of I plus 1 or j, whatever, right? Maybe there are two variables I and j, and you are comparing them. Fine. So when you do this comparison, you have to say, okay, if this is less than 0, then I might like to do swapping or whatever, right? So some logic will be there. The point is, this is how you are going to be comparing. You will be saying, oh, is it less than 0? If you want to know whether it is less than this, right? And the suggestion which I have made, right? What's the suggestion? Add a default method. If the default method was there, fine, then this would have looked much better, right? Okay. Fine. See, this would have looked much better in the sense that, yes, I would have been able to say dot less than this. We don't have to compare with the 0. Fine, don't look for a 0. By adding default method, this is what could have been done. Fine. Okay. Anyway, if you want, you can always be doing another thing here. Okay, because API is that's being managed by Oracle, fine. And so if you are interested, what you could be doing is you could have your own package, right? Package, and you could have my package, whatever the package name you decide. And in that you're saying, okay, I'll have my public interface comparable of some type T extends comparable of it would be java.lang.comparable of t. And here, yes, you can do the methods. Fine. You can just add the public default methods. Sorry. Returns boolean. Method returning boolean less than, and you could say okay. Okay. And your implementation, we understand this implementation now. Return this dot compare to t is less than 0. Right? So you could add those convenient methods, and then wherever needed, you use your mypackage.comparable. See, mypackage.comparable is anyway comparable because it extends from comparable. It's all about types and subtypes, which is where, right? Wherever someone says comparable, you give your version of comparable, and that should be working. And because you have extended from java.lang.comparable. So you could create your own library, right? So you can say instead of my package, maybe a much better name could have been used. Okay, okay, fine. Com dot your company name. Okay, fine. Dot util, and yeah, there you are having a library of so many things, and you could add some more things. Yeah. So what is comparable interface? What is it? It defines the natural ordering for objects of a class, right? So when you define a class, decide does it have a natural ordering? If it has, put implements comparable of whatever the name of the class is. Okay, fine. Okay, then what we should be doing? Define the class public class, and you will have the, okay, I'll just say class name, implements, you'll say comparable of class name. Okay, fine, whatever the class name is. Okay, I've not followed the convention. Normally your type names, they start with capital. Okay, but this is just to indicate whatever is your class name. So any class which has a natural ordering should do this, and if it is not abstract, then at least you will have to use public int compare to for, okay, some variable, and yeah, write the logic here to return an integer value. Right? Logic is based on whether it is, so return less than 0, greater than 0, or equal to 0 according to the current object, right? This is to be compared with the given object C. Fine. Fine. So clear. So we have this standard thing called comparable. Fine, which is for, so you can think, yes, this is giving us the comparison operators for our type. Okay, comparison operators available for our type. Now, okay, so next thing here,